Hello everyone. In this video I would like to make a small demonstration of simulation program done with Modelica. Modelica is a language for modeling and simulation of complex system or multi-physics system. So today I will show you a model of a 6 degree of freedoms robot. So our model here is basically made of three main parts. The first part is here, it's the mechanical part of the robot. The second part is here, it's the axis, so it's basically the motor and the controller of the robot, of every axis of the robot. And we have a global control bus here with a path planning. It means that we want the robot to start to one point A and go to point B at the end of the simulation. So now let's have a look to what is inside the mechanics. The mechanics here is made by 6 joints, 6 revolute, 1, 2, 3, 4, 5, 6 here, corresponding to the 6 degree of freedom of the robot. And as you can see, each of the joint here as a connector, a mechanical connector connected to the axis of the robot that we will see later. In between all of the joints we have the mechanical part of the robot, so it's basically we define for each element of the robot a mass matrix, or inertia tensor if you want, with the global mass and the way the mass is spread in this part. Okay, we also attach a CAD file for animation. So we have this for all the part, and we also have a load, so it's basically just the mass that the robot is moving around. We can parameterize the mass of a rigid body to be moved. Now let's go back to the axis itself. So if we look what is inside the axis, we have basically 3 parts again. The part 1 is a controller here, which is a PID controller. We also have a electrical motor here. So the electrical motor here is parameterized with some inertia gain, time constant and damping constant, maximum speed, blah blah. But actually, if we look what is inside, we have the details of all the components, the electrical components inside. We have all the resistor, all the capacitor of the inductor that are inside the electrical motor itself. So we can go very deeply in detail. And at the end we have a gear, so to reduce the rotation speed of the motor, and some sensors. Okay, so and yeah, now here you can find the connector, mechanical connector connected to the mechanical part of the robot, and we have here a global control bus. Okay. So now I will just show you the simulation itself. So I'm gonna launch the simulation here. We need like a few seconds to be done, and this is the result that we obtained. So as we can see here, we have a detail of the mechanical part of the robot. So in each joint, each revolute, we know the rotation speed here of each revolute here that is given. And we also have an access to all the effort, momentum effort given to each rotation speed. And if we animate the simulation, well, we can follow in real time what is happening, and we have a visualization here of the robot itself. Let's have a look to what is happening on the controller now. On each controller here, we can check what the PID is giving to the motor, actually, because the PID controller controls the motor. So we have an idea of the intensity or current, electrical current that is given to to each motor in each axis. Okay, so we can go very deep in detail here to see what's going on. It's quite complex. And finally, if you remember, I show you that inside the motor we have a capacitor, and we can even have an idea of what's going on this capacitor. So here is the capacitor of the motor of the axis number 6, and we can see that this capacitor has this voltage and this current as well. So basically, to wrap up, just to say that Modelica is a very powerful language to simulate mechatronics and multiphysics system in general, and we can go very in details in any single elementary component of our system. Thank you for watching this video.